Imagine looking at the world not as solid objects, but as a shimmering dance of tiny, energetic particles. This is the quantum realm. It's a place where the familiar rules of our everyday world simply don't apply. Particles can be in multiple places at once, and they can be mysteriously linked across vast distances. For a long time, this strange behavior was just a fascinating puzzle for physicists. But now, we are learning to harness this peculiarity. Quantum technology is the art of using these bizarre quantum rules to build machines and systems that can do things we once thought were impossible. It's not just about making things smaller or faster. It's about creating entirely new ways to compute, communicate, and see the world around us. At the heart of this revolution are concepts that challenge our intuition. One of these is called superposition. Think of a spinning coin. While it's in the air, it's not quite heads and it's not quite tails. It's a bit of both. A quantum bit, or qubit, is like that spinning coin. Unlike a normal computer bit that is either a 0 or a 1, a qubit can be both a 0 and a 1 at the same time. This ability to exist in multiple states at once is what gives quantum computers their extraordinary potential. By using qubits, these machines can explore a vast number of possibilities simultaneously, which is a power that ordinary computers, even the most powerful supercomputers, will never possess. Then there is the phenomenon of entanglement, which Albert Einstein famously called spooky action at a distance. When two particles become entangled, they form a single connected system, no matter how far apart they are. If you measure a property of one particle, you instantly know the state of the other, even if it's on the other side of the galaxy. This instantaneous connection isn't just a scientific curiosity. It forms the basis for quantum communication. It allows us to create secret keys for sending information that are fundamentally secure. If anyone tries to intercept the message, the very act of looking at it disturbs the entangled particles, immediately revealing the presence of an eavesdropper. So, quantum technology is really about taking the fundamental laws of the universe, the very rules that govern atoms and particles, and using them as tools. We are moving from simply observing the quantum world to actively participating in it. We are building devices that operate on the principles of superposition and entanglement, opening up frontiers in computing, secure communications, and incredibly precise sensing. This isn't just an incremental step forward in technology, it's a leap into a completely new paradigm, one that promises to reshape our future in ways we are only just beginning to imagine. The journey is complex, but the destination could redefine what it means to be a technological civilization. The race to master quantum technology has become one of the most significant scientific and geopolitical contests of our time. It's a global competition with enormous stakes, and the leading players are clear: the United States, China, and the European Union. Each has its own strengths and strategies, creating a dynamic and rapidly evolving landscape. This isn't just about scientific prestige, it's about securing an economic and strategic advantage for decades to come. The nations that lead in quantum will likely shape the future of global security, finance, and industry, making this a race that no major power can afford to lose. The level of investment and focus from governments and private companies alike is truly unprecedented. The United States currently appears to have the edge in the field of quantum computing. This leadership is driven by a powerful combination of private sector innovation and substantial government funding. Giants like Google, IBM, and Microsoft are at the forefront, building ever more powerful quantum processors. These companies are pioneering gate-based quantum computers, which are seen as the most promising path toward machines that can solve truly complex problems. The US government, recognizing the strategic importance of this technology, has also put measures in place, like export controls, to protect its lead and has poured billions into research through national labs and universities, fostering a vibrant ecosystem of startups and established players. Meanwhile, China has strategically focused its immense resources on a different, but equally important area: quantum communication. China has made breathtaking progress, establishing itself as the undisputed world leader in this domain. It has constructed the world's largest quantum communication network, stretching over thousands of kilometers on the ground, and has launched quantum satellites into orbit to extend this secure network globally. In fact, China has already conducted tests of a quantum satellite link with Russia. This state-led approach, backed by an estimated $15 billion in government funding, has allowed China to build a formidable infrastructure for theoretically unhackable communications, a capability with profound implications for military and government security. the European Union finds itself in a strong yet challenging position. Historically, Europe has been a powerhouse of fundamental quantum research, with its universities and institutes producing many of the foundational breakthroughs in the field. However, it has struggled to translate this academic excellence into commercial products and large-scale deployment at the same pace as the US and China. To close this gap, the EU has launched ambitious initiatives like the EuroQCI, which aims to build a secure quantum communication infrastructure across the continent. While its funding may be more fragmented, Europe's collaborative approach and deep well of scientific talent mean it remains a crucial contender in this high-stakes technological marathon. The reason for all this intense competition and investment is that quantum technology isn't just a minor upgrade. It's a fundamental shift that promises to solve some of the world's most complex and intractable problems. Its applications stretch across nearly every sector of our society, from medicine and materials science to finance and national security. The power of quantum computers, for example, goes far beyond simply doing calculations faster. They operate in a completely different way, allowing them to tackle problems that are so complex that even the most powerful supercomputer today would take billions of years to solve. This is the true significance of the quantum leap. One of the most exciting applications is in drug discovery and materials science. Designing a new medicine or a revolutionary new material, like a superconductor that works at room temperature, involves understanding how molecules interact at a deep quantum level. Simulating these interactions is incredibly difficult for classical computers. However, a quantum computer is perfectly suited for this task because it operates using the same quantum principles. It could simulate molecules with perfect accuracy, allowing scientists to media group, scientists developing new medicine, researchers examining pills, Alzheimer's research lab at stock, @distribute_equally, design new drugs to fight diseases like Alzheimer's, develop new catalysts to capture carbon from the atmosphere, dramatically accelerating the pace of scientific discovery and innovation. In the realm of security, quantum technology is a double-edged sword. As we've seen, quantum communication, through something called quantum key distribution, offers the promise of perfectly secure channels for sending sensitive information. This would be a huge benefit for media group, government officials meeting, bank headquarters exterior, military strategy meeting at stock, @distribute_equally, governments, banks, military operations protecting critical data from spies and hackers. However, the same power that makes quantum computers so useful also makes them a threat. A sufficiently powerful quantum computer could, in theory, break the encryption that currently protects nearly all of our digital information from media group, emails on computer screen, online bank transaction, government data center at stock @distribute_equally, emails, bank transactions, government secrets. This creates a critical race to develop new quantum-resistant encryption before that day arrives. Beyond computing and communication, quantum sensors are poised to revolutionize how we measure the world. These devices use the delicate nature of quantum states to detect tiny changes in their environment with astonishing precision. This could lead to media group, MRI scanner in hospital, neurologist examining brain scan, detailed brain imaging technology at stock, at @distribute_equally, medical scanners that can detect brain activity in unprecedented detail, navigation systems for submarines that work deep underwater, where GPS signals can't reach, by sensing minuscule variations in Earth's gravitational field. Quantum sensors could also be used for media group, geologists surveying landscape, mining engineers with exploration equipment at stock, @distribute_equally, mineral exploration, monitoring volcanic activity with far greater accuracy. In essence, they provide a new set of eyes with which to observe the universe, from the smallest particles to the largest celestial bodies. Looking ahead, the future shaped by quantum technology is filled with both immense promise and significant challenges. On one hand, we stand on the cusp of a new era of innovation. The positive applications are almost boundless. Imagine a world where logistics for global shipping are perfectly optimized, saving vast amounts of fuel and reducing emissions. Picture financial markets where risk is modeled with near-perfect accuracy, preventing economic crashes. Or consider the creation of new, highly efficient solar cells and batteries, designed atom by atom using quantum simulators. This is the exciting future that drives researchers and innovators forward. A future where we have the tools to solve some of humanity's greatest challenges. However, this powerful technology also brings with it profound worries, particularly concerning security and inequality. The most immediate concern is the quantum apocalypse, the moment when a quantum computer becomes capable of breaking our current encryption standards. This would render our digital world, built on the trust of secure communication, dangerously vulnerable. It would not only affect future communications, but could also be used to decrypt vast archives of sensitive data that have been stolen and stored over the years. This threat is forcing a global effort to transition to new forms of cryptography, but it's a race against time, and the consequences of losing could be catastrophic for global stability and personal privacy. There is also the risk that quantum technology could widen the gap between nations. The immense cost and expertise required to develop quantum systems mean that only a few wealthy countries and large corporations are likely to master them initially. This could create a quantum divide, where some nations possess unimaginable advantages in intelligence, military capability, and economic power, while others are left far behind. The potential for a new arms race, this time fought with quantum algorithms and entangled particles, is very real. Ensuring that the benefits of this technology are shared widely and that it is governed responsibly will be one of the great diplomatic challenges of the 21st century. In summary, the quantum revolution is well underway. We are learning to speak the universe's native language, using the strange and wonderful rules of quantum mechanics to build powerful new tools. The race for quantum supremacy is being led by the US in computing and China in communications, each pursuing a different but vital piece of the puzzle. These technologies are important because they hold the key to solving problems in medicine, energy, and security that are beyond our current reach. While the future is uncertain, filled with both the hope of a better world and the fear of new dangers, one thing is clear. The quantum age is coming, and it will change everything.